children away. All right, let me turn off my fish. 5 fish. Okay. All right. Hello. Everybody remember what's happening tomorrow? No. Okay. We're having a quiz tomorrow. 6-1 through 6-4. All right. I'm going to pretend like everybody's there. Anybody have any questions from homework stuff? Or general questions about what we've done so far? Somebody's here. Nope, you guys are okay. I love it. All right. So if there's no questions from homework or anything, we're going to get back into where we left off. So last time, so let me kind of bring us back up to speed, and then I want to get to look at some more complicated problems you'll see in the homework. Let me see. I finally got some new markers. Come here. All right. So yesterday we got into section 6.5, which had stuff like this. Right? Let me see. Can you guys all see that all right? That's neat. Not sure what that means. Let me do this way. Bam! Okay. So guys, somebody out there tell me
I got it.
how many A's would be left and where?
In the bottom, A3.
Yes. Because there's 5 on the bottom. 2 cancel, 3 are left on the bottom.
Yes.
So it is still subtraction. It's just the result's going to be where they would have been left alive. I kind of think of them as survivors. 2 kill each other. There's 3 survivors down here. And of course, for the B's, how many and
5
where?
on top?
5 in the top.
Yeah, 5 on the top. And again, it's still subtraction. It just, the answer is going to be where most of them were in the first place. That's where they would have survived. So I'm hoping that makes sense, as always. Okay, so that was kind of like the basic idea we went into yesterday. So let's look at something more challenging. Let's see. Let me pull one right out of here. Yeah, that one looks pretty good. All right, let me do one like that. Become a 3. Oh, Jeebus. So this has got just a little bit more going on. And the way you look at this really is there's a top problem and a bottom problem. And on top, there's 2 different problems. So when I look at this problem as a math person, I see this as here's one problem, here's another problem, here's another problem. Let me focus on those first and then see what to do next. Maybe? All right. You guys try to do the next step. Simplify each of these mini problems here.
To be honest, I don't know.
Sorry?
I don't know.
So looking at this first one, look just at this first guy. What's 3 squared?
5, 3, 2.
So
Oh, I got it. 9.
yes,
9 square.
you know what exponents mean. They mean that number of those things multiplying. So if I
9
multiply
square.
2 3s, I'll get 9. Yes?
Yes.
A to the what now?
4.
4. And of course, b squared.
B square.
I like it. So that's that
Yeah.
problem done, right?
Mm-hmm.
And you guys keep going. Just finish
8.
this up. Do that problem and that problem by yourself.
8.
By yourself. Don't say
Okay.
anything aloud.
Okay.
Yeah. Whoever is actually out there. Okay, so now I think Hayam, you gave this away. 2 cubed, 2 times 2 times 2 is 8. Somebody else. And then a cubed cubed, a to the third to the third. What would that be?
27. 8, 27.
No, no, nope.
It's a 3 cubed, right?
No, it does. Nowhere in here does it say 3 cubed. Nowhere. It says a cubed cubed.
A cubed. Okay.
If I had 3 A3s, A3, A3, A3.
27.
No. Okay. A cubed cubed means
9.
A cubed multiplied 3 times. How many A's is this? 3, 3, 3. 3, 6, 9.
9.
What's the shortcut? When you have a power raised to another power, you multiply the powers.
Okay. I got it.
So then this will be A to the 9th, B to the
6.
6th,
12.
so then 6 squared.
12.
No, that's 6 times 2, not 6 times 2. That has its own notation already. 6 squared must mean something different. It means 2 6s multiplied.
36.
Yes.
Oh.
Exponents can only mean one thing. They mean that many of the base multiplied. That's all it means. Now, I'm not coming down on you, Hayam, because until you're more familiar with this, you've got to stop and tell yourself, that's what this means, that's the answer. That's what this means, that's the answer. If you just kind of go and let your brain just take over, it's going to start just putting the numbers together however it wants to at that moment. What happens here? A cubed squared.
6.
6, and then of course b squared is b squared. That's amazing.
Okay.
Okay, so we're not done. We're not quite close to done yet, right? But this is where people start to give up a bit, is when they're like, oh my God, how long is this problem? Oh, well, get the problem done. What's the next thing I can do? There's actually a couple next things you could do, but it's better to go ahead and multiply the top, and then it can cancel with the bottom, right? So what do I get on the top if I multiply that stuff? 9 times 8.
72.
Yes. A4 times A9. A to the 4th times A to the 9th is A to the 4 A's times 9 more A's. I have A to the 13. B squared times B6. I see 2 b's. I see 6 more b's. So altogether, I see
8.
8, b to the 8th. And on the bottom, I've just got this business. All right. So now the last thing you have to do, now that you got these two figured out, you combine these two, you know what the top is, you know what the bottom is. Now you just divide, right? Feels like we're playing bingo, B8, bingo. What's 72 divided by 36?
2.
So 2. A13 divided by A6. How many A's would be left? A to the 13th divided by A to the 6th. How many A's are left? So when you divide, you subtract powers. 13 minus 6 is 7. 8 minus 2 is 6 B's left. So all this business becomes that in the end. And that's a 6 down there if you can't see it. So yeah, some of these problems are going to have multiple steps, right? You just do it. You don't skip it. You don't try to force the answer to come out early because you're not going to get it right. You just go through the steps. Okay. That's one of the more complicated problems you'll see in section 6.5. All right, now one thing I really like that they do, and not just because I'm evil, right? We know I'm evil, but it's because it's really good for learning this shit, is they put this mixed practice in. So after you're doing a bunch of problems like this, I'm gonna erase this. Anybody still need this up here? It's being recorded.
I got it.
Go ahead, erase it.
The spokespeople have spoken. All right. Look at the thing, Jeff. There you go, buddy. In the middle of all that, they give you this problem. Something like this. Because you need to not only understand each process, you need to be able to identify when to do what process. So what is 14 M7s minus 3 M7s?
11.
11 what?
11M, 7.
Yep. I'm just keeping track of how many M7s I got. I had 14. Somebody took 3 of them away. Dang it. Brr. So now I only got 11. Well, something that really drives me a little insane is, here's another problem. Somebody will tell me this. Do not write that down. Do not write that down. Do not write that down. That makes no sense. I have 19 8 of the 7s. I add 3 more 8 of the 7s. And all of a sudden, you got 22 A14? Where the hell did these come from? I don't see any of these. How do you have 22 of them? Right? What do I have 22 of? I have 22 A7s. Now, listen, here's a big note to take. The only time that exponents can change is if I am multiplying or dividing with them. Because what are exponents based on? Multiplication. I'm going to mute everybody. Don't unmute yourself until you have a question to ask. Okay. I'm going to mute everybody. Don't unmute yourself until you have a question to ask. Okay, let's see what that holds. All right. Okay, so let's see. So then what about this? Let's do a couple in a row here. What if I had 3a to the 8th plus 7a to the 8th? What would that be? If you want to
10a
say it.
to the 8th.
Sorry?
Is it 10a to the 8th?
Yes, 10a to the 8th. All right, I like it. What if I had 3a to the 8th times 7a to the 8th?
10.
Not 10, it's multiplying. 3 times 7
It's
is
gonna be
21.
21.
A to the,
8.
no, nope,
16.
16. Now listen, guys, listen. The only time exponents can change is if you are multiplying or dividing, because exponents keep track of how many letters are multiplying. I got 8 A's multiplying here, right? Times 8 more A's. So now there's 16 A's multiplying total. Up here, I got 3 of something plus 7 more of that thing, so I have 10 of those things. I was not multiplying or dividing, so why would the exponents change? Exponents are based on multiplication. That's the only time
Okay.
they change. When you multiply or divide.
When we have multiply, we add the
Yes.
up one, the 8.
Yes.
Okay.
When you multiply like bases, you add the powers.
Okay. The powers.
Again,
Okay.
never forget why that makes sense. Can you guys see in your head a string of 8 A's right there? And then put next to it another string of 8 A's. How many A's total you got? 16. I mean, so the rules of powers are just based on what exponents mean. They just keep track of how many of that letter I've got. If I got 8 here, 8 more, I got 16. Savannah.
When you divide, do you minus?
Yeah. So we
Okay,
talked
got
about that yesterday. So let's try this. Let's try another one out. Let's see. So what would this be?
Would it just be 7y?
Yeah. 21 divided by 3. I don't care what we learn. 21 divided by 3 is 7. Just because we learn more shit to put in there does not change what 21 divided by 3 is. I get people that put 18 down. Do you guys see where 18 would come from? Yeah. They subtract it, and then they come up to me and they say, but you said you subtract when you divide. No, I never, ever would say that. That doesn't make any sense. Subtraction is not division. They're not the same thing. When I have powers, I subtract them. And again, you guys cool with the fact that there is no 4 anywhere in this whole problem? There's no 4. No 4 anywhere, right? There are 4 Y's. And they cancel, and 3 of them cancel out. So of course there's 1 left. So what's the shortcut? 4 minus 3 to see how many's left. So you can memorize the properties, but make sure you understand in the first place why the property makes sense, right? This would be 7, y. So Andy, you got another question, or you just never put your hand down? Okay, all right. Okay. What's this? Let me see. Let me do 2 in a row here. What do you got, Jeff? That's a 3 there, by the way. All right, Jeff, stop it. So what's 24b cubed plus 2b cubed?
26b cubed.
Yeah, I got 24 somethings plus 2 of those same things is 26 of those things. That's all like terms means, is the coefficient changes because you're keeping track of how many the thing there is. But what's 24b cubed divided by 2b cubed? If I were you, I'd write it like this. I understand you might not be able to see this yet. Hold on. Yes, you can see. Right, 24b cubed divided by 2b cubed. 24 divided by 2 is?
Would it just be 12?
12. I love it. And two ways you can think of. Don't the b cubes cancel? Yes. But aren't you supposed to subtract? What's 3 minus 3?
0.
0. But what's b to the 0?
B.
No.
1.
Yes. If you think b to the 0 equals b, then you think that 0 equals 1, which is a little crazy, right? B to the 0 means I ain't got no b's, so I can write it without any freaking b's, right? That kind of makes sense. Okay, all right. Maybe.
Maybe.
Okay. So just take some practice, and you have to have the rules sitting next to you or reference them as you do each problem, because that's how you get used to the correct application of the rules. If you just sort of do what you think at the moment, you're not reinforcing the correct rules. So it's not cheating to have the rules sitting next to you as you're doing your homework. That's how you should do homework. I like it. It's the quizzes you can't use shit like that. Okay. So let me see real quick. I want to make sure there was nothing else weird in this section. Well, let me do a couple more with you. Oh, I see. Okay. Nothing too weird. All right. Let me see. What's this here? What's interesting is when we start learning more and more, we sort of forget what we used to know. I forgot what I used to know. So what is 6a squared plus 5a cubed?
11.
No, it's not 11 anythings. What would it be 11 of? I have 6 of these plus 5 of those. Are they like terms?
No.
Nope. So you can't do shit.
No.
If there's a problem that says simplify this, you could just say already simplified, or you can write it and circle it, right? Because that's as far as it can go. You can't do anything to it. Do you guys see that? They're not like terms, right? So when you start learning more exponential rules, old stuff like this suddenly gets lost, because then you're worried about, do I add, do I multiply? This is adding. You're adding two things. They must be like. They must have the same letter and the same amount of each letter for you to be able to add them together. If it was 6a cubed plus 5a cubed, what's that?
11 A3.
Yes, good. 11 of these. Because I can consolidate it then, right? If I have 6 elephants and then I have 5 more elements, got 11 elephants. If I have 6 elephants and then I get 5 grasshoppers, I ain't got 11 elephant grasshoppers. I mean, that's kind of freaky. I can't put them together because they're not collecting the same type of thing. I can't consolidate them. All right. So that's why I like that mixed practice, because as you learn more stuff, you don't want to lose what you used to know. What you used to know keeps being true. It can't suddenly not be true because now we're in section 6.5. No, that doesn't make any sense. Okay, maybe Crockett. All right. Let's see. Jeff is going crazy. All right, so I kind of teased this a bit. Let me see if I can get this to load up.
Excuse me?
Yes.
When we have divide the 24b cubed and divide 2b3, we're gonna have minus the cubed. Minus?
Subtract, that's the shortcut. You subtract powers when you divide like bases, yes.
Like when we have multiply, we have add.
Yes, see, isn't that a beautiful analogy? When I multiply like bases, I add. So when I divide like bases, it makes sense that I would have to subtract.
When we have a divide, we have subtract. I got it. Okay.
Yeah,
Thank you.
that's a beautiful analogy.
And
I love it.
when we have the I forgot, the plus, we have the same.
They have to be
It's
like
gonna be
terms
the
for you to
same.
be able to do it. Yeah.
The same. Okay.
And
Thank
don't
you.
say you got 11A6.
No,
I don't
no,
have
no,
any A6s,
11A3.
right? Huh?
Gonna be
Yeah,
the
because
same.
you're just consolidating how many of these you've got. The power cannot change unless I am multiplying or dividing.
Okay.
That's the only time the power can change because that's what
Yeah.
powers are based on.
Okay.
It's multiplication.
Easy. Easy.
Do you guys see what I'm saying? I mean, this is I don't think very many teachers get that deep into it, but the deeper you get, the more the rules make sense. So I could just tell you the rules and say, memorize these. But you gotta accept why they work. Why are they there? They're not just rules we made up. They're rules that we noticed.
Okay.
There's a difference. Okay, I like it. All right, so. So any other questions from 6.5 before we take a baby step into 6.6? The first part of 6.6 will be relatively simple, and the second part of 6.6 will be relatively difficult. So we're going to do the first part of 6.6 today, and then I think tomorrow I'm going to devote the time to the second part of 6.6. All right, so I'm not trying to freak you out, just trying to let you know there's a little bit of a weird thing, something we're not used to at all, but once you see it a few times, it'll still be weird, but it'll be easier to do, hopefully. All right, so the first part's not bad, and then somehow it relates to this.
Okay. I have a question before
Okay.
you begin the 6.5. 6.4, 345. I'm sorry.
6.4.
345. Yeah, 345. I'm gonna mute.
Oh, okay. Somebody, we looked at stuff. I know this isn't the problem, by the way, right? But you know me, I'm not going to do that problem for you. Does somebody know something special about what's going to happen here when I multiply these? Something special happens to the two middle terms. And if you forgot, let's
They
take a look.
combine.
They combine, sure, but they
Why?
combine in a special way. They kill
Okay.
each other.
They cancel.
They cancel. There won't be any middle term. So x squared minus xy
Oh,
plus
okay.
xy
Okay.
minus y squared. So the problem you're talking about has more shit in it, but the same thing is going to happen, right? Is that all right, Hayam?
Yes, I got it. I got it. It's like the okay.
Okay. So
Thank you.
coming back, if my computer will go. There you go, computer. So somehow 6.6, the beginning of 6.6 relates to this. What is 3/5 plus 1/5? Stop it, Jeff.
4/5.
Yeah. And just to remind you guys, that is like terms. 3/5 plus 1/5 is 4/5. It's just the idea of like terms. Look at Jose showing off fractions in the text. I like that. So 4/5. I love it. That's amazing. So I can do that process backwards. So now watch this. 10/7. Stay with me now. I'm not saying you ever want to do what I'm about to do with numbers. We're going to want to do what I'm about to do with letters. Isn't that equal to 7 plus 3/7? Is that, anybody find that amazing? No. Good. All right. I like it. What the hell? Now watch this. I can then do like I did here. I can go backwards. I can break this back up. This is 7/7 plus 3/7. Is anybody not okay with any step I just took? Started here, 10 is that. I can break them back up, right? If I went backwards, wouldn't that be 7 sevens plus 3 sevens is 10 sevens? Same thing, thank you. But what is 7 divided by 7? This I can do.
49.
What? 7
49
divided by 7.
divided. Okay, sorry. It's 0.
No.
1.
1. 1. Yes.
Oh, divide. Oh my God.
1. It's all right. It's okay.
I forgot what is the divide.
It's all right. It happens. You guys semi with me? I know you would never do that this way. Am I right? You would do 7 into 10 once with 3 left over. Isn't that how you change it to a mixed number? Right? Maybe. But this is another way to kind of look at it. So when is this useful then? Watch this. All right. So how would I do this? The thing I need you to realize is you can't just cancel those B's and then that would be your answer. That cannot work that way because what is being divided by B right now?
1.
All right, let's try. Be careful. What's on the top? B squared plus 4B. What's being divided by B? Both of them. So if you cancel that B, that's not fair. How did he escape? And even more fundamentally, what's division the opposite of? Multiplication. So there's no way in hell division can cancel part of an addition problem, right? It can't do that. Okay, so how do you do this thing then? The way we just did. What's being divided by B? B squared is being divided by B. And 4B is being divided by B. Now look at that, what I just wrote. Look at that in a different way. If that was the original problem, get in there. And I said combine those. Do they have like denominators? Do these have like denominators?
Yes.
Yeah, they have the same thing on the bottom. So couldn't you combine them then? That plus that over B, and isn't that exactly what this says? So the way to look at a problem like this is you break it up, and then each one of these is its own problem. What's B squared divided by B? How many B's are left?
1.
Yeah. And then what's 4B divided by B?
4.
4. I like it. All right, let me see if I can push this a little bit. Anybody have a question about what the hell just happened? I'm going to show you something kind of cool, and then we'll do a few more examples. Notice this. Can anybody tell me what type of polynomial is on the top?
A binomial.
Good. And what type of polynomial is on the bottom?
Monomial.
Monomial. Dividing by a monomial is easy. You break up each term on the top over that thing, and then you simplify each piece. That's how you divide by a monomial. The second part of 6 is dividing by a binomial, which gets really nifty. All right, so let me show you something. What was I about to show you? I was about to show you something. You can do it, Jeff. There it is. All right, sorry. Help me out. What is 10 divided by 2?
5.
Yeah.
5.
How could you check that real quick? It's kind of dumb, but what's 10 divided by 2 equal 5 mean? It means that 2
To multiply 5.
times 5 is 10. You with me?
Yes.
Okay, now watch. Didn't we just say that B squared plus 4B over B equals B plus 4? Right? Isn't that what we just did here? So I'm going to erase this. How could I check that then? Here I checked it. 2 times 5 is 10. So how can I check this? What's B times B plus 4?
B4.
B
B4.
Squared.
Square.
Square. Who was that?
What?
What was that? The squared is my favorite. I'm the sacred square. B times B is B squared. B times 4 is 4B.
Before.
Is that what we have up top? So 5 times 2 is 10. Check. B plus 4 times B is B squared plus 4B. Check. Check, 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 check. All right.
Okay.
Okay. I'm going to mute everybody again. Only unmute yourself when you're ready to talk. All right. So now watch this. So, you guys take a second and try this one out. All right. It's not too bad. Nothing too crazy yet. I'm going to take a drink of what's supposed to be tea. Oh my gosh. All right. A little drink, a little sniffy sniff. Whoa, I'm ready. So the first step is to break this up. This is both of these pieces are being divided by 2a. So you write it exactly like that. So you would rewrite this as 4a cubed is being divided by 2a. And 10a squared is being divided by 2a. Then you look at that as a problem, and you look at that as a problem. Right? Here, 4 divided by 2 is 2. And then 3 minus 1 is 2. So I get 2a squared. Is everybody cool with that? Is anybody not cool with that? All right. And then over here, 10 divided by 2 is 5. I had 2 a's divided by a, so I have 1a left. 1a left. Yes, somebody's telling me yes, thank you. I like the positivity. Okay. Now watch this. Let's do one more that's got a little bit more interesting stuff to it. So everybody got this? Let me erase this up here. Watch this here. Let's see. You can do it, Jeff. There you go, buddy. Look at you go. The most common mistake is for somebody to cross through these and then write that as the answer. That is a little, let me see if I can do this. All right, stop it, Jeff. That's a little insane because division cannot cancel parts of a subtraction addition problem. It just can't. The only way to correctly do this is to break it up into 3 parts, right? So this one had 2 parts, bam. Did somebody just join in? What happened? So here I got to break it up. 8x squared over 8x squared minus 16x over 8x squared. Do you have to say it each time, Jeff? No. There you go. Right. Each one of those is being divided by 8x squared. If you thought you could just kill these and write that answer, that doesn't make any sense. These were being divided by this, and suddenly they get free from that. That's not fair. So what is 8x squared divided by 8x squared?
1.
1 is the loneliest. All right. Things get a little more interesting over here. 16 divided by 8. That's not the interesting part. And how many x's are left? And where? When I reduce the x's, how many are left? Where?
Oh, 1x. On
Where?
The bottom.
On the bottom.
On the bottom.
Right? Ooh. And over here, what's 4 divided by 8?
So 1 over 2x squared.
And the x squared is still there. There's no other x's there to mess with those, so they just hang out. You got to be careful about, is the result on the top or the bottom? right? That's always going to be a part of these simplifying fractions with letters in them. Maybe. Okay. Now, I think the last thing I want to do today is kind of lay some groundwork for tomorrow. Tomorrow, we're going to get into the second part of section 6.6. And believe it or not, it really hinges on your ability to remember how to do this by hand. So do that by hand. Long divide that out. And I'm going to do it too in a minute. So I'm not going to just make you do it by yourself. Because just because I get some perverse pleasure of imagining how horrible this sounds to you, the rest of 6.6 is about long division of polynomials. Now that sounds awesome. I know you guys were like, why didn't we do that on the first HF? Come on. I love long division, period, but throw some polynomials in there? I know, I'm being like a sarcastic asshole. I'm sorry. But if you understand the process we use on this problem, you will be able to understand the process we use in polynomials. They have to be the same process because what are variables? Numbers I don't know yet. So how do variables work? The same way numbers do. They have to. They're not going to look the same, but they're going to act the same. So how the shit? All right, so first off, of course, you write it like this. Now, if anybody's being honest out there, do not touch your calculator. Oh, shit, I lost somebody. Okay, they're coming back in. I want you to be really honest here. Anybody that did it totally by hand, how did you figure out the first step? Anybody? Okay, Yansha, so, and did anybody else get 6 as the first number? I want you to really figure out, look in your brain for a second, because it's 6. 6 is the number you put up there. Why? Did you think about 81 and 498, or did you think about 8 and 49? You thought about 8 and 49. You did. You just did. And if you try to do a few of these and capture what your brain is thinking, that's what your brain was thinking. I don't have to think about 81. I can just think about 8. 8 goes into 49 6 times, right? 6 times 8 is 48. So 6 is a great first guess, right? We'll see if it works. It should work. It might be a little off. We'll have to see. What is 6 times 81? 486. Are you guys, is everybody with me? I know we're doing, number one, maybe it's been forever since you long divided by hand. So you got to kind of remember the steps. And number two, we are doing a deeper dive into your thought process for how to do this, right? All right. So then what's the next thing that I do? I know this is simple, but just tell me.
Minus 8.
Yeah. Now watch. I'm going to say it in a really strange way. 6 times 81 is positive 486, correct? Right? And I'm not changing the way we do long division. I'm just getting us ready for the weird things we got to do with polynomials. I'm going to change the sign, right? Didn't I just change the sign? I know I subtracted, but can't I look at that like I changed the sign? Now I put these together. So I get, there you go, Jeff. And then of course we
Add the 2.
bring down the 2.
122.
1.
Yeah, 8 goes into 12 once.
1. Yes.
1 times 81 is 81. Subtract, I'll get 41. Now, here's something that I would not let you do on this problem, but it's the way we're going to do polynomials because they're numbers I don't know. I can't do polynomial decimals. That's a phrase you never wanted to hear. Thankfully, I don't do them, right? We don't do them. So we're not going to do decimals here, but can somebody write what the fraction would be here?
61.
What's the remainder? What's the remainder? 41. Do you guys remember how to do this? What's the fractional piece I could put here? Right? No? No? Are we okay?
I don't know.
Let's try, let's do real quick. I don't want to leave this. I want to do some of this in a minute, but can you do 11 divided by 7? What's 11 divided by 7? 7 into 11 once, right? And then how would you write the fractional remainder? 1 and 4/7. I know you know that. Maybe it's just because these are bigger numbers, but it's the same idea. When you write this as 1 and 4/7. So I'm going to remind everybody, I'm going to mute everybody again and only unmute yourself when you actually have something to say, and then mute yourself right away. All right, I'm going to keep going because we desperately should know this. This is how you change an improper fraction into a mixed number. That is the method that's most often used, right? Now watch, I want to show you something nifty about this. Now I'm going to let you use your calculator real quick. What is 61 times 81? I think it's 49, 41, yes. 61 times 81. Does anyone have that answer?
You're gonna add in the bottom 41 and in the top 41 and in the bottom 80.
What is happening? So all I'm saying is, what is 61 times 81? That's all I'm saying. 49, 41. Now watch. So 5 goes into 10 evenly, right? That's amazing, I know, but 2 times 5 is 10. You with me? So 61 times 81 will not be 4982 because there's a little extra, isn't there? 61 times 81 is, what was it? 4941, right? Yeah. And what is, God, right now I'm doing a little extra. I'm doing a little extra, but I really, really want, please tell me you guys can see this. How do I check a division problem? Don't I do this times this and see if it makes this? Isn't that how I check a division problem? So 81 times this piece is that much. What's 81 times 41 over 81, right? 81 times 41 over 81. Don't those cancel?
4982.
And when you add those together, you get 4982. Yeah. Right? Okay.
Right.
So this was a reminder about how long division works. Just to give you a little teaser, next time we're going to look into how to do this problem. Get out of there. Right? Divide that polynomial by that binomial. That looks impossible maybe at the moment. But I'm going to do another problem like this next time, remind us all about the steps, and then we're going to apply the exact same steps to this. Believe it or not, right? Ripley's. Whew. Otherwise, let me see. I think that's all I got for today. Anybody have any questions? The quiz tomorrow is on 6-1 through 6-4.
The Wi-Fi disconnected on me, so I missed the problem that you did.
All right, I'm going to post the whole lecture up to YouTube like I've been doing, so you can catch it there if you want.
Okay, good.
Yeah. So don't forget YouTube, I'm posting all these up there, right? So if you miss, or if you fall asleep, or if you just don't come, you can catch up.
Thank you, Professor.
Yeah. Does anyone have any questions? Want to hang out for a minute? If not, I am fine with that. But if you need to,
Tomorrow we have a class, right?
what's up?
Tomorrow we're gonna have a class to Zoom.
Yeah, yeah.
Okay.
The link that I sent out works for all the 4 classes this week.
Okay.
Yep.
Right. Thank you. Bye-bye.
You're welcome. Anybody else have question? Let me see. Bye. Bye, everybody. I'm going to watch all the bubbles pop, 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 pop. All right, I'm headed out. I don't see any questions. Bye, guys.